Lesson 5.5, using similar figures. By the end of the lesson, you're going to be able to use proportions to find missing lengths in what's called similar figures. And I'm going to be explaining what similar figures are in a little bit. But first, this is a real-life example of what you can do with similar figures. Now just watch this. Please don't copy this. Now let's say you are standing right next to a flagpole and you're wondering how tall this flagpole is. You had no way of measuring how tall this is. I mean, you don't want to climb up and break your back. But let's say this flagpole has casted a shadow right here. And let's say you also casted a shadow and you knew how tall you were. You can actually measure the shadow here, your shadow, and how tall you are, and use those three lengths to figure out how long this flagpole is, or how tall it is. Now let me show you. So if you knew this length and these lengths, you can actually find out what x is. And that's because these two triangles are similar triangles, and I'll explain what similar is in a second. But first, let's look at polygons. Here I separated some shapes into what's polygons and shapes that are not polygons. So take a minute, think to yourself, and pause here. Think to yourself, what might be considered a polygon and what might not be considered a polygon? Well, polygons, you might have noticed that first of all, they have to be closed shapes. Now, closed meaning that they can't be open like this shape over here. Like this shape over here. There's a gap in this shape, so that's not a polygon. Now, you might also have noticed that polygons have straight sides. They can't have rounded edges like the circle here and this shape over here. There's one more thing. Polygons can't have their sides overlapping like the star over here. This side overlaps with other sides and that won't work. So our definition for polygon is a closed figure formed by three or more line segments that do not cross. And these line segments mean that they are straight line segments, not rounded, straight. Let's go over what similar polygons are now. We know what polygons are, and I'm going to just bring down this polygon over, and we're going to use this. Now a similar polygon, I'm going to copy and paste, is a polygon that basically stretches or shrinks proportionally. So for example, if I shrink it like this triangle is similar to this triangle. And let me make another one. If I stretch it like this, these three triangles are similar. Now what is not similar then? If I just stretch them, well, if I take this triangle and I stretch it this way, and I don't stretch it like, well, basically if I stretch it unevenly, so for example, this is our original. If I stretch it like this is similar. But if I stretch it like this, or like this, it doesn't create a similar polygon. And I hope that's clear. One more thing I want to mention is that similar polygons can be also rotated. So if I rotate it like this triangle is still similar to this triangle. And I'm going to leave this like this. And I'm going to go over something called corresponding angles and corresponding sides. And the word corresponding is key here. What corresponding means is basically angles or sides that match up to each other. So let me take my pen and I'm just going to look at this angle over here. Now which angle is corresponding to this angle? Which angle is matching up with this angle? Well, of course it's this one. So these two angles are corresponding angles. How about in this triangle? Which angle matches up with this angle? Well, it's not this one or this one, but it's this one over here. So these are called corresponding angles. And we can do something similar with corresponding sides. We take a side, let's say this side, and of course the corresponding side would be this one, and the corresponding side in this similar triangle would be this one. It's basically the side or angle that matches up with the original. So I'm going to bring that in. Sides are angles that relate or matches up to the original. And that is corresponding angles and corresponding sides. Next page. Okay, so there are a couple things that are really interesting about similar polygons, and I listed them here. Corresponding angles have the same measure, and corresponding sides form equivalent ratios. Now let's first look at this one. Corresponding angles excuse me, have the same measure. Now what that means is that angles that match up, corresponding angles, they're exactly the same. And I'm going to show you by looking at, let's say the red one I circled here. I'm going to bring this down a little bit, and I'm going to take this triangle and show you that those angles will fit perfectly into each other. So we're looking at this one right here, and it's going to fit perfectly into this part. Same thing if I look at this angle, and let's say I take this big one, I rotate it. This big one is going to fit perfectly into each of these angles. Corresponding angles are similar. Let me rotate it back. The second thing that I mentioned is that corresponding sides form equivalent ratios. And what this means is that we can write proportions based on the sides. Now let's look at this example. This side is corresponding to this side. This side here is corresponding to this side. So what we can write is a proportion. You write 6 over, and we can write 12. We write it as a proportion. So this side corresponds to this side, so we write the 3 on top. These two correspond to each other. And n we write on the bottom. Now this is a proportion, and you all know how to solve proportions. Cross multiply. So we can go ahead and cross multiply. And what do we have? We have 6 times n, which is 6n, is equal to 3 times 12, which is 36. Now 6n is equal to 36. How can we get n by itself? How can we solve for n? We can divide by 6 on both sides. And right here we have n is equal to 6. So these two similar trapezoids, this value would be 6 here. Okay, let's do another example. This one's a little bit more complicated, and I'm asking for 3 things here. Angle Q, which is this angle, angle A, which is this angle, and length AB, which is this side over here. How long is this side? Now, we're given that these two triangles are similar. So we can go ahead and use these rules. So let's look at angle Q. We know that corresponding angles have the same measure. So Q, we don't know yet, but we have the corresponding angle over here. And angle B. These two angles are corresponding. They match up to each other. So if B is measured 53, Q has to be 53 degrees as well. Wasn't that simple? Let's look at angle A. Angle A we don't know, but angle P is corresponding to angle A. P is 92 degrees, so A has to be 92 degrees as well. Aha! Okay, now length AB is the more difficult part, because this is a side length. This is how long this is. Now let me clear this up really quickly so we can see the picture. Oops, I erased my angle Q. Angle Q we found out was 53 degrees. Okay, so length AB is this part. We know that this side here is corresponding to AB. So what we can do is set up a proportion. I'm going to let this be a variable x, because we don't know this, and I can set any variable to the side length. So I can go ahead and write a proportion. So let's write a proportion with this length and this length. And I'm going to pick some numbers from the other two side lengths that we know for both triangles. So let's look at 16.8. This side corresponds to this side here, but we don't have this side length, so I don't want to use that. What I want to use is this one over here, because we have the corresponding side length in the other triangle. So let's look at the numbers that I circled. We have x here, so we can write x here, over, and on the other proportion we can write 8, because these two are corresponding. Over here we have 21, and that's corresponding to the 14. Notice that these two numbers here, the x and the 21, belong in the same triangle. These two in the same triangle. 8 and the 14 are from the same triangle. Now all we do is solve the proportion. Cross, multiply. X times 14 is, that's right, 14x. I'm going to move this up a little. Oh, let's move this. Yeah, it's okay. X times 14 is 14x. And 8 times 21 is 168. To get x by itself, we will divide by 14 on both sides. And if you do work out the math, we get x is equal to 1, 2, so 12. Okay, and that is the length of this x over here, the side AB. This is 12. And we want to keep the units. This is in feet, so 12 feet. Okay, so I want you to try this. Pause here. There's two problems over here, number 1 and number 2. Pause there, and I'll show you the answers in 3, 2, 1. Okay, and if you got these wrong, please review, please rewind and check your answers and see what you did wrong. Okay, reply with a question or respond to a question on Edmodo and take the quiz. That's all for today. Bye-bye.